In order to convert an NFA into a DFA, it's a pretty simple process. Here we have a basic NFA, and we'll just trace through it like we've done before. If you don't really know what an NFA is, you can watch our video on NFAs linked at the top right. So as we did in the other video, we'll just make a simple table over here where we have the state and then the possible inputs. So for our first state, we can see that on start we enter Q0, but because it has an empty transition leading to Q1, we also enter Q1. So our start state is Q1, Q0. For these states, on input 0, we can see that Q0 does not lead anywhere, but Q1 transitions into Q3. So our output will be Q3. Now for input 1, we see that Q0 goes to Q2, and Q1 goes nowhere, so our state is Q2. Next, we'll test the inputs on the states that we were able to reach. So for state Q3, on input 0, we see that there is no transition, so we'll cross that out. But on input 1, we see that it loops back to itself, so the output will be Q3. Lastly, for Q2, we see that on input 1 and 0, there is no transition, so we have no output. In words, this NFA would accept either the input 1 or the input 0, then 0 or more 1s. If we were writing the regular expression for this, it would look something like this. 1 or 0, then some amount of 1s. If you want to know more about regular expressions, you can watch our video on that at the top right. Now, since we have this table, it's fairly easy to convert into a DFA. We just make a state in the DFA corresponding to each state that we were able to reach. So here we'll draw our DFA. For our start state, which we'll label Q0, that actually corresponds to our Q0 and Q1 start. Following the table, we can see that on input 0, we go to Q3. So Q0 will lead to Q3. And we see that on input 1, we go to Q2. So Q0 will go to Q2 on input 1. For simplicity, I'll just highlight any that are accept states. So Q3 is an accept state, and so is Q2. Next, for Q3, we see that on input 0, it goes to a trap state, which means it's completely rejected. Now, the key difference between an NFA and a DFA is that a DFA is deterministic. This means that each input has one transition. Depending on how strict you are with your DFA, you may not show routes to a trap state, but for this example, I will. So on input 0, this goes to a trap state we'll call Q1. And since it's a trap state, we'll make it loop back for 0 and 1. And we see that for Q3, on input 1, it loops back to itself. Lastly, for Q2, we see that both inputs here go to a trap state. So we'll have both of them, 0 and 1, lead to Q1. And that's it. We've converted an NFA into a DFA. As we mentioned previously, the regular expression for this was 1 or 0, 1 star. So we can test that here. On input 1, we go to an accept state, so that part holds. On input 0, we go to an accept state, and however many 1s we enter after that will stay at that accept state, so this holds as well. One last thing to note was, let's say we had a state Q0, Q3, and this is an accept state. If we were in the state on a DFA, we would consider this as an accept state. What I mean by that is, if that was a possibility, then we would have something like this, Q4, and Q4 is going to be Q0, Q3, and that's an accept state, because Q3 is an accept state. If you like this video, you can check out some others on the channel. Thanks for watching.